Welcome to my YouTube channel. This is A Square Maths Made Easy Academy. Now, in my today's video, I'm going to continue with the first 100 questions under calculations in what? Calculus. Now, we have already taken from 1 to 7. Are you with me now? So, in my today's video, I'm continuing from question number what? 8. Remember, I'm just solving it in every ramification. Why I said so is because if you observe my previous video, you agree with me that I was able to solve both the normal method and the shortcut what method. So now let's continue from where we stop. Now today's question starts from number what? 8. Now let's watch. Now the question says, find the derivative of y equal to x squared log x exponential. Now look at this. Question number what? 8. Now the question says we should find the derivative of y then equal to x squared then log what? X exponential. Now this particular problem is what we call differentiation by product what rule. I want you to understand this, that the word derivative means dy dx. If you can't call it dy dx, you can call it differentiation. Are you with me? Now this is no longer chain rule. This is a product of two functions. This is the first one and this is the second one. So now I'm going to use the formula method for product rule first. Let us see whether we can get the answer. Now what are we going to do? Using differentiation by product rule. By what? Product rule. Now what is the formula? Look up. Now we are given that y is a function of uv. This is product. Now all this we are going to differentiate them with respect to what? X. Let's start with y. If you differentiate y with respect to x, it will give you dy all over what? Dx. Then we now move to the right. Now how do we differentiate this u and v? The law is you should put the first one constant, which is u, and differentiate what? V with respect to what? X. It will give you the v all over what? Dx. Now product means addition. Go with what? Addition. It's multiplication, but I want you to understand that we use addition for the product once we have differentiated the first one. Now the next thing is to put the second one constant, which is what? V, and differentiate u with respect to what? X. It will give us the u all over what? Dx. Now this is what we call differentiation by what? Product rule. Are you with me? Another way we can satisfy this formula is this. I want you to observe this. This dy dx simply means f prime of x. F prime of what? X. And it's given us, now you watch this. This is u. U is just a function which is of what? X. I will now call it u of what? X. The next thing is dv dx. Can you see there is differentiation here? How do we sort it out? We call it v prime of what? X. The reason is because the word prime means means differentiation. Means what? Differentiation. Then I will now add. Are you with me? Then v now we put it just constant and it is v of what? X. Here there is differentiation. Now this is u with respect to what? X. I will now call it u prime. U what? Prime of what? X. Now this is another way of introducing product rule. It can appear in prime form. It can appear in dy dx what form. Now if that is known, can we move now? Now starting from the formula, the first value which is x squared, we consider it as what? U. And the second one which is log x exponential, we consider it as what? V. Now let's go. We can now say let u be equal to x squared. Now if u is equal to x squared, I'm differentiating u with respect to x. Now this will give me the u all over what? Dx. Then it's now equal to, can we differentiate x squared? First of all, consider the power. What's the power? 2. Then you multiply. The second thing is to repeat the question. The question is x raised to power 2. And finally, introduce minus 1. And that is a general formula for differentiation. Can I continue? Now this is 2 times x will give us 2 what? X. Then raised to power 2 minus 1, which is 1. I can call it 2 what? X. That is the answer for du dx. Then we now move to the second one, which is v. Let v be the second, and the second is log x exponential. Now, before we differentiate this, I want you to get it clear that another way of writing log x exponential, we call it ln x. We call it what? Ln x. Then let's differentiate v with respect to x. What are we going to get here? V with respect to x will give us the v all over what? The x. Then equal to. Then the question, how do we differentiate ln x? The word ln means 1 over the function. And what is the function? X. Are you with me now? I'm giving the secret. Then after that, you multiply and differentiate the x. You know, if you differentiate x is what? 1. I have already said it in my last video. Then let's continue. This will now give us 1 times 1 is 1 all over what? X. So which means the derivative of log x exponential is 1 over what? X. Now let's go to the formula and substitute. Now we now say dy all over what? Dx is now equal to, what is the first one? U. What is the value of u? The value of u is x squared. Is what? X squared. Then the next thing is dv over dx. Look at it. dv over dx is so. What is it? 1 over x. I will now say dot 1 over what? X. Then I go with addition. Then after that we have v, right? What is the value of v? Look at it. v is what? Log x exponential. Then I will multiply. Lastly, du dx. What is du? Look at du dx. What is the value? 2x. I will now write here 2 what? X. Are you with me now? Now, do you agree with me this? That the power of x here is squared, and down here we have just x. So one of these x down, we cancel one of these x up. What remains is just x. X times 1 will give us what? X. Are you with me now? Then plus log x exponential times 2x will give us 2x log what? X what? Exponential. This could have been the final answer. But if you observe this particular problem, we can factorize. What is common? X and what? X. Factor what? X and open the bracket. Now as x divided itself, it will give you 1. Then plus, when x cancel x, what remains is 2, right? I will now call this log what? X exponential. Close the bracket, and that is the final what? Answer. Then my question is that, is anything like this in the option? Let's watch. X squared plus no. X minus 2 log x exponential. No. Look at option C. X bracket 1 plus 2 log x what? Exponential. Now the correct answer in the option is option what? C. And that is how to solve this problem using what we call the normal what? Method. But the question is there any way we can approach this using shortcut what? Method? It is possible. I want you to watch. Okay, now let us approach this particular problem using shortcut. But before then, permit me to give you the steps for solving differentiation by product what? Rule. Now the first step is this. You should put u constant. Put u constant and differentiate what? V. Then the second thing is to introduce plus. Are you with me now? Then the third step is to put v constant, and differentiate what? U. Very simple. And differentiate what? U. Then finally, which is the fourth one, simplify to have what we call dy dx. That is all. Can we move ahead now? Now the question says that y is equal to x squared log what? X what? Exponential. Now my target is to differentiate y with respect to what? X. I will have dy all over what? Dx. Now this is equal to. Can we follow the steps now? Now this is u, right? And this is what? V. Let's follow the first step. Put u constant. What's the value of u? X squared. I will now put x squared here. Close the what? Bracket. And differentiate what? V. V is log x exponential, right? And I have told you, anytime you are differentiating log x exponential, it is 1 over the function. And what is the function? X. Then you multiply. After differentiating, consider 1 over x, you now differentiate this x. I have told you that this is invisible what? 1. How do I differentiate this? I'll use the power to multiply x. It will give me x. 1 times x will give me what? X. Raised to the power of 1, then introduce minus what? 1. Come on, can we go ahead? This is x, right? 1 minus 1 will give you what? 0. By the law of indices, anything raised to the power of 0 is what? 1. So which means if I'm to differentiate log x exponential, the result is 1 over x. Am I communicating? Then what is the first step? Introduce what? Plus. And this is the plus. The third step is put v constant. What is v actually? This is v. V is log what? X exponential. Close the what? Bracket. And differentiate what? U. And you know that u is x squared, right? I want to differentiate it now. Du all over what? Dx is now equal to, consider the power. What's the power? 2. You multiply and introduce what? X. You raise to the power of 2 minus 1. Are you there? Then 2 times x will give us what? 2 what? X. And this 2 minus 1 is 1. So what is it? What will be the correct answer? It is 2 what? X. When you differentiate what? X squared. Then I will now go here and introduce 2x. Can you see already the answer is there? The answer is what? There. So what do we do? Do you agree with me that one of these x will cancel one of the x up? Remaining just x times 1, which is x. Then plus, this times this will give us 2x. Then log what? X what? Exponential. I would have stopped here, but it is not in the option. So what do you think that we do? We factorize. What is common here? X. What is common here? X. I will factor what? X and open the bracket. As x divide x, it will give you 1 plus x divide this, it will remain 2. Then log what? X what? Exponential. And that is the final what? Answer. Do you know that if you cannot see this like this, I can call it x bracket 1 plus 2 ln what? X is still the same thing. Have I made myself clear? Now this is what we call what? Shortcut. Permits me now to go to question number 9. Question number what? 9. Now let us observe question number 9. Look at the question. The question says, given g as a real valued word function, g is a function. Now the question is, find the domain and range of what? G of what? X. And g of x is given as square root of x squared minus 1. Now how do we find the domain of this function? Remember we are question number 9 and the question says g of x is equal to square root of x squared minus 1. Now be careful here. Am I communicating? I want you to observe something here. First of all, I want to use what we call try by error method. Let's start with the value of x when x is 1 as the domain and substitute into this equation and know whether it exists or what not. Let's try it. This is square root, right? What is x? X is 0. 0 square will give you what? 0. Then minus what? 1. If you continue, you have square root of 0 minus 1 is minus 1. Can you see that this kind of problem does not what? Exist because there will be no range. So which means x can never equal to 0, cannot be the domain of this word g. Now I will increase it and call it x to be what? 1. Let's substitute and know what we are going to get here. So we have this, right? Square root of, what is the value of x? 1 square, right? Minus 1. And that will now give us square root of, what is 1 squared? 1. And 1 minus 1 is 0. Oh my goodness. Can you see that now? The square root of 0 is what? 0. So the domain x is 1. What will be the range? 0. Permit me to try again with minus 1. When the domain is minus 1. Whether it exists or what? Not. Can I substitute again? This is square root of, what is x? Minus 1 all what? Squared minus 1. And that will now give us square root of, do you know that minus 1 squared, the minus will disappear. It will give us 1 minus 1. And 1 minus 1 will give us what? 0. Square root of 0 is still what? 0. Can you observe something here? When x is 1 as a domain and when x is minus 1 as a domain, the range are what? The same. Permit me to try when the domain is 2. Am I communicating? Can we substitute now? It will give us square root of, what is x? X is 2, right? Then all squared minus what? 1. And that will now produce square root of, what is 2 squared? 2 squared should be 4, right? Minus 1. And what is 4 minus 1? It is 3, which is square root of 3. And square root of 3 will give you 1.73 something. Am I communicating now? Then finally, let me try when x is minus 2. Can I substitute again? It will give you square root, what is x? Minus 2. Then all was squared minus 1. I want you to appreciate this. When you multiply minus 2 twice, the minus will disappear, which means minus 2 squared can give you 4 minus 1. And the result is square root of 3. And square root of 3 is 1.73. Am I communicating? Can you see that now? When the domain is x is 2 and the domain is minus 2, the range is also the same. The same thing applicable to when x is 3 and when x is minus 3. You will still get the same value. So one thing I want you to observe here, the only thing that contradicts the domain is what? 0. So which means 0 cannot be the member of this particular word function. How do I summarize it? I want you to observe here. I can now say that the domain of G, am I communicating, is now equal to, remember that 0 is not a member, but every other element, both negative and positive, is a member. How do we say it? I can now say it is a member of real number minus then member of what? 0. This is the answer. I want you to understand what I mean. All the set of real number except what? 0. Because every other number of x exists as domain of this function. But 0 saying no what? No. That is the answer. Am I communicating? Or another way of writing this, you can say it is what? A set of real number, not 0. Am I communicating like this? It's still allowed. Or I can say the domain of G is set of what? X, such that x is a member of real number and x is not equal to 0. Have I made myself clear? Now, this is the three basic way you can see it or approach it. Am I communicating? Now, can we now look for the range now? I'm talking about range of what? G. So let us observe the result. If you look at what is happening here, when x is 1 and minus 1, which is 0. Now, what is the minimum value of the range? Here is 0. Increase to 1.7. It will also be increasing. Increasing to where? Positive what? Infinity. So in summary, what did I say? In summary, that the range of G is member of what? 0, block 0. Then comma, plus what? Infinity bracket. And that's 2 is the final word answer. Let's check the options here. Look at the option. The real number minus this, and block 0, comma, plus infinity. Yes, this is the domain and this is the word range. So the correct answer in the option is option what? A. Are you with me now? That is exactly how to appreciate this particular word question. Now, having done number 9, now can we look at question number 10? What did I say? Question number what? 10. What is question number 10? Remember, I am solving questions on calculus. That is 400 questions on what? Calculus. And this is what we call exam tip, both theory and what? Objective. Now we are heading to question number what? 10. What is number 10? I want you to watch. Number 10 says that we should evaluate limit of 2x squared then plus 3x minus 1 then all over x squared plus what? X, as x approaches what? Infinity. Option A says 0, option B says minus 2, option C says 2, and option D says indeterminate. Now, this particular question, we call it limit to infinity. What did I say? Limit to what? Infinity. I want to use the normal method to solve this first. Then after that, I'll use what we call shortcut. Are you with me now? Can we start now? The question says limit of what? 2x squared plus 3x minus 1. All over what? X squared plus what? X. Are you with me now? All over what? X squared plus what? X. As x approaches to what? Infinity. Now look at the proceeding. Consider the highest variable power and use it to divide both the numerator and the denominator. The highest variable power is x squared. Is what? X squared. So how am I going to do it? I want you to watch. I will now say limit as x approaches what? Infinity. Open bracket. Let me start with the numerator. This is 2x, right? 2x what? 2x squared divided by what? X squared, which is the highest power. Then plus, the next one is 3 what? X divided by what? X squared. Then minus 1 still divided by what? X squared. Then divide by the denominator. What is the denominator? S squared divided by S squared plus X divided by what? S squared. Are you with me? Close the what? Bracket. That's the first step. Followed by the limit as X approaches what? Infinity. I want you to watch. S squared will go with S squared, right? What remains there is 2. Then plus one of the X here will cancel X down. What is remaining? 3 all over what? X. Then the next one is minus 1 over S squared. Remember that this one cannot cancel. We move to the denominator. Now watch. S squared over S squared will give you 1, right? Then plus one of the X here will cancel 1 down. It becomes 1 over X. Close the what? Bracket. Now what do you think that will happen here? What does X tends to? X tends to what? Infinity. Am I communicating now? Now as we are substituting what X tends to, what do you think that will happen? Anywhere you see X from here, remove it and introduce what? Infinity. It will now become 2 plus 3 all over what? Infinity. Minus 1 all over infinity. Please don't say infinity square. We don't have anything like infinity what? Square. Infinity is what? Infinity. Then all over, what is here? 1, right? Plus, I have seen X down again. Call it what? 1 all over what? Infinity. Can we continue? The law says, as the limit, are you with me now? As the limit of X approaches to what? Infinity. Look up everybody. A number over what? Infinity is always what? 0. So which means when the infinity is at the denominator and there is a number which is a real number at the numerator, the limit of that function is always what? 0. Remember when X approaches what? Infinity. Oh yeah, let's go. This is now 2, right? Plus 3 over what? Infinity. There is this, right? It is what? 0. Minus 1 over infinity is what? 0. Then all over, this is 1, right? Plus 1 over infinity is what? 0. At the end, 2 plus 0 is 2, minus 0 is 2. Then divided by 1 plus 0 will give you what? 1. What is the answer? 2 over 1 will give you what? 2. Do we have 2 in the option? Let's watch. Oh my goodness. The correct answer is option what? C. This is the normal what? Method. Let us view it using what we call shortcut. What did I say? Shortcut. What is the formula? The question says, limit of 2x squared plus 3 what? X minus 1 all over. This is x squared, right? Then plus what? X. As x approaches what? Infinity. Now what you should do, remember the law, we consider the highest variable power. They are 2 and 2, right? This one does not exist because the power is lower than these 2. This one also does not exist because it's a constant. This one also does not exist because it's a constant. And what is the power? 1. But imagine now, what about this? Are they not the same? This s square will cancel this word s square. Finally, what is remaining? 2. And that is the final word answer. Do we have it there? Yes, still option word C. Have I made myself clear? Now, this is question number 10. That is how to solve limit to what? Infinity. Let's move to question number 11. Question number what? 11. Now, what does the question say? I want you to watch. Number 11 says this. Question number 11. A function f of x passes through the origin, through the what? Origin. Passes through the origin. And its first derivative is 3x plus what? 2. Now the question is, what is f of what? X. Can we take a look at the options? A says 3x all over 2 minus 4 plus what? K. Option B says 3x squared all over what? 2 minus 2x plus what? K. Option C says 3x squared minus 4 plus what? K. Then option D says 3x squared all over 2 plus, are you with me? All over 2 plus 2x. Then plus what? K. Now look at this question. The question is this. What actually are we looking for? If you are not careful, you may misinterpret the question. Now, this is called integration. Do you know why? Let's read the question first. A function f of x passes through the origin, through the word origin, and its first derivative, underline the word first derivative, is what? F of x, 3x plus what? 2. And they said, what is what? F of x. This is what we call first derivative, f prime of what? X. And it's given as this. Look up 3 what? X plus what? 2. You know by right, this thing means dy all over what? Dx. And it's now equal to 3x plus 2. Look up. When a question starts with what? Differentiation, what comes to your mind is integration. The reason is because opposite of differentiation is what? Integration. Are you with me now? So what are we going to do? Call this over what? 1 and cross what? Multiply. Dy times 1 will give you dy. Then equal to, this is 3 what? X plus what? 2. Are you with me? The x times this will give you what? Dx. Finally, what do we do? Can you see we have differentiated dy from what? Dx. Because this is x, right? So you now integrate both sides of the equation. What did I say? Integrate both sides of the what? Equation. Now the law is this, watch. Integrate dy is going to give you y. And this y means f of x. Means what? F of x. Somebody may ask, how do I know it is what? Y. Am I communicating now? Now look up. Integral of dy. What is the coefficient of dy is 1. And 1 is a constant. 1 is what? A constant. How do you integrate a constant? The law say, repeat the constant, bring the constant, multiply it with the variable, which is y. Am I communicating? 1 times y will give you y. If I'm giving only this integral of the x, what is the constant again? 1. Bring the 1, multiply it with the variable, which is what? X. 1 times x will give you what? X. This is exactly how to integrate a constant. What if you are given this? It is called integral of du, right? And this is an invisible one. The law said consider that constant, which is 1, multiplied by the variable, which is u, and 1 times u will give you u. That is exactly what happens here. Invisible what? 1. Consider the 1, just like I said, multiply with the variable, which is what? Y. 1 times y will give you what? Y. And another way of writing y is called f of x. Then what do we do to the right? Look at the principles of integration. Let's integrate 3x squared. The first thing, bring the question 3x. Am I communicating? Invisible what? 1. The law of integration says add plus 1. Integration is always plus what? 1. Then after that, you introduce over and bring back the power down to the denominator. What is the power? 1 plus 1. I am done with this, gentleman. It's just like somebody saying, integrate something like this. What you should consider now is, bring the question, which is x squared. Are you with me? Integration means plus 1. Having done that, you now bring the power down again to the denominator to become x2 plus 1. And at the end, the answer is x raised to power 3 all over what? 3, then plus what? C or K. And this is a constant. We call it arbitrary what? Constant. Now I will show you why. Can we continue? Now, having done this now, this is plus, right? This is a constant. You will now bring the constant, multiply by the variable. What's the variable? X. I am done. So finally, I'll put an arbitrary constant, which is plus k. Do you know why? This type of integration is called indefinite. But if it is like this, it is no longer indefinite. It is called definite integration. This is bounded by upper limits and lower limits. But when there is no 1, there is no any number here, it is indefinite. So anytime you integrate it, after everything, put plus k or plus c, and that thing is called an arbitrary constant. Can we fire on? F of x is now right. This is 3 what? X. 1 plus 1 will give you 2. All over what? 2. Then plus what is here? 2 what? X. Then plus what? K. And that is the final what? Answer. Can we observe the option? No. Oh my goodness, it can't be this. Look at it. Here is minus and here is plus. No. Okay, look at this. The correct answer in the option is option what? Option what? D. Have I made myself clear? Now, we have done this. Then the question now is, how do we solve this problem now using shortcut? Already they said its first derivative. You should know that it is integration. I'm going to integrate 3 what? X. Are you with me? Then plus 2. And how do I do it? You just say 3x, right? Invisible 1. put it and add plus 1. That's the formula for integration. Then bring it down, 1 plus 1. I'm done with this. Then plus, this is a constant, bring it and multiply with the variable, which is what? X. Finally put plus k. This is shortcut. Then if you continue, you have 3x. What is 1 plus 1 is 2, right? Then all over 2, right? Plus 2x plus what? K. That is the answer, using what we call shortcut. Do you understand? Now the next question I want to share with you is question number 12. Question number what? 12. Now watch this. Question number what? 12. I'm rounding up. Number 12. Now look at this question. The question says that we should evaluate integral of 2 brackets. What do you have? 2x minus 3 raised to the power of what? 3 over 2 over 3 under what? Dx. Under what? Dx. Now the option says, look up. Option A says 2x minus 3 plus k. Option B says 2 over 3 open bracket. Then we have 2x minus 3 raised to the power of 5 over 3 plus what? K. Option C says 3 over 5 open bracket 2x minus 3 raised to the power of 5 over 3 plus what? K. Then option D says 6 over 5 open bracket 2x, are you with me, minus 3 raised to the power of 5 all over 3 plus what? K. Now this type of integration, some people will look at the question and they will be wondering, how can I use just a second or a minute to solve this problem, and I will discover it in the option. It is possible. Can I shock you now? I want you to observe. Now look at the question. Let's go. Solution. I want to use shortcut first. I want to use shortcut first on this question. Now the question says integral of 2, right? Bracket 2x minus 3 raised to the power of 2 over what? 3 under what? Dx. Under what? Dx. Are you with me now? Under what? Dx. Now what do you think that we'll do here? It is very simple. Now watch. This thing, the first thing we are going to be using shortcut is first of all to differentiate the one inside the bracket. And the one inside the bracket is 2x minus 3. I'm applying differentiation. That's what we call differentiation by substitution, integration by substitution what? Method. It governs both differentiation and what? Integration. When I'll be teaching my lesson proper, I will educate you on how to solve all these problems. But watch. What do we do next? Oh my goodness. The law is apply differentiation first. You know that if you differentiate the one inside the bracket, 2x will give you 2, right? Then this one is a constant, throw it away. Now the law of this now is that it has obeyed what we call substitution law. Integration by what? Substitution. Do you know why? The law is that once you differentiate the one inside the bracket and x vanishes, it means that that thing can go by what? Substitution. But if the question is like this, I want you to watch. Oh my goodness. Oh my goodness. Can you observe this particular question now? Then if you differentiate this now, what will it give you? 4x. Can you see that x is still remaining? This cannot go by substitution method. That's what we call integration by parts, which I will still teach you. Then let's continue. What do we do? It is very simple. Now can you see that this 2 here has cancelled this 2 here? So what do you think that remaining? Bring it back. 2 what? X minus 3. Close the bracket. What is integration? 2 over 3, right? Add plus 1. Remember we introduced over, right? Bring it down to the denominator. I will now say 2 over 3. Then C plus what? 1. Finally put plus what? K or plus C. Now let's go. Can you discover that this is what? 2x minus 3. Close the bracket. What is your LCM? 3. But just say 3 times 1. What is it? 3. It becomes 2 plus 3 divided by what? 3. The same thing here. 2 plus 3 divided by what? 3. Then plus what? K. Do you know that this gentleman will go down according to the law of indices? How? If I'm given 2 all over 5 over 6. Do you know that this thing means 2 divided by 5 over what? 6. Change it to multiplication. It becomes 2 times 6 over what? 5. Can you see that 6 have migrated what? Up. So which means this 6 will go up. Then what happened here? 3 will go up. I'm now having 3, right? Then bracket. What is here? 2x minus 3. Close the bracket. 2 plus 3 is 5 over 3. Are you there? Then all over what? What is here? 5. Then plus what? K. This is the final answer using shortcut. Let us discover in the option. Oh my goodness, look at this. 3 over what? 5. 3 over what? 5. Open bracket, 2x minus 3, close the bracket, raised to power 5 over 3 plus what? K. So which means the correct answer is option what? C. This is what we call using shortcut. Am I communicating? But I'm going to use the normal formula now, which is called integration by substitution. What did I say? Integration by what? Substitution. Then watch. Using what we call integration by substitution to solve this. I said integration by what? Substitution method. It has a pattern. Watch my 7 months video ago. You will see I was able to discuss more on integration by what? Substitution. Check it. Just type integration. Now, what do? I want you to observe something here. Am I communicating now? What is my target? Look up. This is a constant, right? But first of all, I will say let my u be 2x minus 3. That is the first thing. Let u be 2x minus what? 3. The next thing is to differentiate u with respect to x. It will give you the u all over what? The x, right? Equal to. If you differentiate 2x, it will give you 2. I've said it before. Am I communicating? This is a constant. Throw it away. Then throw this over 1. What is my target? To make the x subject of the formula. I would cross multiply. The x times 2 will give me 2dx. Are you there? Then equal to. The u times 1 will give me what? Du. Then make the x subject of the formula. That is why we call it by substitution method. I will divide this by 2. I will divide this by 2. 2 will cancel what? 2. So what remains is the x. And the x is the u all over 2. We have done that. Next thing is to go back to the question. Are you with me? And substitute. Integral of 2 bracket 2x minus 3 close bracket raised to the power of 2 over 3 under what? The x is now equal to, factor these 2 out, then integral. Remember that this is given as u raised to the power of what? 2 over 3 under what? The x. Do we know the x? Look at it. The x is the u over 2. I call it the u all over what? 2. Now, what do? Factor these 2 out. Or rather, these 2 down here, up here, we cancel these 2 down here. What do you think that is remaining? Integral of u raised to the power of 2 over 3 under what? The u. Can we integrate again? Repeat the question. What's the question? U raised to power 2 over 3. Integration say put plus 1. Then overwrite. Repeat the power down to the denominator. 2 over 3 plus 1. Finally put plus what? K. If you continue, you have u. 3 times 1 will give you what? 3. Then it becomes 2 plus 3, which is what? 5 over 3. Am I communicating? Here also will become 5 all over what? 3. Remember what I said? 3 will move up. If 3 should move up, you begin to have 3u raised to power 5 over 3. Then all over what? 5. Then plus what? K. And this is plus what? K. Are you with me? Then finally, what did I say? Finally, what? Finally, what do you have? You now substitute for u. Substitute for what? U. So it becomes what? 3 brackets. This is u, right? U is 2x minus 3 raised to the power of what? 5 over 3 divided by 5 plus what? K. And that is the final answer. We call it integration by substitution. We call it what? Integration by substitution. So gentlemen and ladies, I will stop at question number 12. My next video, I will continue with question number what? 13. Now please don't forget to subscribe. Please share it. Comment in the comment section. And also please share the link everywhere. Now this is what? A Square Maths Made Easy Academy. See you in my next video when we'll be observing question number what? 13. Bye.